A star blew itself apart, then it blew up again. That sounds like bad science fiction, but astronomers now say they finally have visual proof that at least some stars really do die this way, not in one blast, but in two. The evidence comes from the remains of a long-dead supernova called SNR 0509-67.5. It is the wreckage of a star that exploded hundreds of years ago, but even now, that wreckage is still glowing, still expanding, and still holding the fingerprint of what happened. And that fingerprint is strange. At first glance, this looks like a beautiful circular cloud in space. But when astronomers studied it with the Very Large Telescope in Chile, they found something hidden inside it. Two separate shells of calcium, one inside the other. That matters because calcium should not be arranged like that if the star died in one detonation. It does make sense if the star exploded twice. The star itself was a white dwarf, the dead core left behind after a sun-like star runs out of fuel. Normally, white dwarfs just sit there, small, dense, and quiet. But if one is locked in a binary system close enough to another star, it can begin stealing material. That is where the danger starts. For a long time, the standard picture was simple. The white dwarf steals matter, grows heavier, reaches a critical limit, and then detonates once in a Type 1a supernova. That model has been used for years because Type 1a supernovae are incredibly important. They help astronomers measure cosmic distances, and they helped reveal that the expansion of the universe is speeding up. But there was always a problem. Some evidence suggested that not every Type 1a supernova waits until the white dwarf reaches that final mass limit. Some might die earlier through a different trigger. In the double-detonation model, the white dwarf steals helium instead. That helium builds up like a blanket around the star. Eventually, it becomes unstable and ignites. That first explosion is not the end. It sends a shock wave racing around the star and inward through it, and that shock triggers a second detonation in the core. First, the stolen outer layer blows, then the star itself follows. Astronomers had predicted that a double detonation should leave behind a specific signature long after the blast is over. Two distinct calcium shells in the remnant. And that is exactly what they found. This is the first clear visual evidence that the double detonation mechanism is real in nature. Not just possible, not just simulated, real. That matters far beyond one dead star. Type 1a supernovae are some of the most important measuring tools in astronomy. Their brightness is so consistent that scientists use them like cosmic markers across enormous distances. If we want to understand how reliable those explosions are, we need to understand how they begin. And now the picture may be changing. At least some of the explosions we trusted as standard may come from stars that never reach the mass astronomers once thought was required. They may die early, triggered by a stolen layer of helium, and leave behind a double scar that stays visible for centuries. That is what makes SNR 0509-67.5 so powerful. It is not just debris, it is a confession. A star exploded, then exploded again, and the evidence stayed written in space long enough for us to find it. Which means one of the most important explosions in the universe may have been misunderstood the whole time. And the proof was sitting there, expanding in silence, waiting for somebody to look closely enough to see the second blast still written inside the first.